Hello guys, welcome to Bugs in Code. The problem that I'm going to explain today is second smallest number. But before that, if you are new here and a person who likes stuff related to coding, then you can subscribe the channel so that you get notified when I push a new video. So let's get started. Here is the problem statement, and it says that the task is to find the second smallest number with a given sum of digits as s and the number of digits as d. Okay, so this problem is basically the next version of the problem, which is smallest number, where we have to find the smallest number instead of the second smallest. Okay, so let me explain the problem, and I am going to use this example. So the example says that hey, you're given d as 2 and s as 9, which means you have to find the two-digit number which is having where the sum of digit is 9, and you have to find like the second smallest number possible. Okay, so let me write all the numbers where it is like two-digit numbers where we have sum as 9. So the first number is 90 for me, like 8172 and 63 and 5445, and I have 36, I have 27, I have 18, and I have 09. Should I consider this? No, I'm not going to consider this, because here we have first digit as 0, but we want our first digit at least 1. Okay, so now out of all these numbers, you can see that the smallest possible number is 18, and the second smallest possible number is this 27. So 27 is going to be my output for this problem. Okay, now I hope you guys have got the clear understanding of the problem statement. Like, we have to find a d-digit number where we have the sum of digits as s, and we have to find the second smallest possible number. Okay, now let me move to the solution. Okay, so the problem says that give me a d-digit number, okay, where the sum of digits should be 9, like s. Fine. Now let's take, we have like n numbers which are d-digit numbers and the sum as s. So let's take the maximum possible number is a. After that I have b, c, d, and I have a lot of numbers. So it is basically in descending order. Like, this is the greatest, and when I move to up direction, then it becomes smallest. So let's take L and M here. So these are the numbers, and now if you observe this series, then you will find that this is the smallest possible number. So it is the smallest number, and this particular number is the second smallest number, isn't it? Because this series is in decreasing order. Fine. Now I can write one observation. The observation is, I want you to listen carefully here, because this observation is very important. So the observation is second smallest number is going to be equal to next greater number of the smallest number with same sum, like same sum of digit. Okay, so now I have written my second smallest number in terms of the smallest number, but you will say, why you have written this observation? So I am going to tell you the intuition behind this observation. I know how to find the smallest number because I have already done that problem. So if you are someone who have already done that problem, so you will write like your new solution in terms of this solution, because you already know the concept for finding this. Okay, but if you are someone who don't know how to find the smallest number, so I want you to assume that there is a function like func which gives you the smallest number, and it's, for this time, let's take it's a magical function. We will talk about the implementation of this function in detail later, but for this time, let's take it is a magical function, because currently I am interested in like telling you the concept of this solution, and after that we will talk about this. Fine. Now we have written one observation that the second smallest number, like second smallest number L, is the next greater number to this smallest number, there is no doubt, and the sum should remain same, like sum should be preserved. Okay, so now let me take an example. So I'm going to write an example which is 1 2 3 4 5 6. I have this number and I want to increase this number, like I want to find the next greater number which is having the same sum. So how you are going to find it? Let's talk about the intuition, like how we can get the intuition. You will say that one observation that I can make is I can choose any two adjacent numbers, okay, and I can increase this by 1 and decrease this by 1, like increase by 1, decrease by 1. Why 1? Because I want the change to be the smallest change, like smallest change, and I want to increase this number in the smallest change possible. So it looks like it's a nice way of doing it, because I'm increasing this by 1 and I'm decreasing this. Why decreasing this? Because I want the sum to be preserved. So preserve the sum of digits. This is very important, because at the last I want the sum to be s, like same. Okay, fine. So when I do so, I will get my number as 1 2 4 3 5 6. Not bad. It is a greater number. It is a greater number, and it is having the sum of digits as s. So it's a good start. Now can we like, what if I say this is wrong? This is wrong. Why this is wrong? Because we have a smaller number possible, which is like I have a smaller number possible which is having the same sum of digit as s. So we have like smallest, this is not the smallest number, I can say it. So what is a smaller number? Instead of choosing these two digits, I will prefer to choose like these two. And when I choose these two, then I will have the new number as 1 2 like 3 4 6 and 5, and you can compare these two numbers which which is more close to this number. So you will find that this number is more close to this number, and so this is the second smallest number. Now you will say that what difference it has created, like choosing these two and choosing these two. I will say, in order to have the smallest possible number, we have to choose the rightmost two digits. Why the rightmost? Rightmost because the contribution made by these digits to this whole number is smaller in comparison to contribution made by these digits. Like this is like 3000. This number is 3000 plus 456, and this number is 50 plus 6. So if I change this number like 5, if I make 5 to 6, then only the difference of 10 will be created. So, and for this the difference of 1000 will be created. So that's why I am choosing the rightmost digits. Okay, so let me write the first observation that I have made. The first observation is choose rightmost two digits. After that, increase left digit by 1 and decrease right digit by 1. Fine. After that, this is my first observation. Okay, and now I want you to take a number which is, okay, so let me erase all this. Now I'm going to take some other number. So let me take some other number. Some other number that I can take is 1 2 3 4 9 and 9. For like these are digits. Okay, fine. For this number you will say that, hey, I know the concept. Choose these two digits. Okay, increase this by 1, decrease this by 1, and this way I will get 1 2 3 4 10 and 8. Quite simple, right? But this is wrong. Why this is wrong? Because it has d digits, and now this number has d plus 1 digits. So the problem that is created is because of this 9. I want you to tell one thing, that 9 plus 1 becomes 2-digit number, but I want a single digit at one place. Okay, fine. So what is how to handle this? In order to handle this, what I will do is I will choose the rightmost digit which is not equal to 9. Listen carefully what I'm saying. I'm saying that rightmost digit, fine, as I said here, but this digit should not be equal to 9. So now I'm going to modify my observation. Now I'm going to rewrite my observation as, hey, you said choose rightmost digit, fine, but like digit should not be equal to 9. So I'm going to write here that rightmost digit should not be, like shouldn't be 9, fine. And this is how we are going to like do this. So what is this? If I choose these two digits now, so I will get 1 2 3, I will increase it by 1, so it will become like 5 and 8 and 9. So this is the again the smallest number possible which is greater than this, and then sum of digits is obviously going to remain same because I'm increasing 1 by 1, so I'm doing like plus 1 minus 1. So this is total 0, and this is how the contribution made by like adding and subtracting is 0. Fine. So now I'm going to write the pseudocode for this. I hope you guys are clear what approach we are going to use. So if I have a number like, now I'm going to write the pseudocode. Observe this. I have a number which is having d digits, and like let's take the same number 1 2 3 4 9 and 9. Okay, so I'm going to start from the rightmost like index, so it is d minus 1th index because d digits are there. So I will start for I equals to d minus 1 and I is greater than equal to 0 and I minus minus. Now inside this, if my if my array of I double equals to 9, then I have to do something else. I have to do something. In else condition I will write break, because if I have found a digit which is not equal to 9, in this case I am going to break, and else in else condition I am going to store the particular index. Why? Because I want to have this particular these two digits. So I will find this digit and this will become index minus 1. So let me take a variable which is index, which is initially equal to d minus 1, like which is initially the last index. Okay, fine. Now I will take like this possible number. I will take this possible number. So okay, instead of taking this let's take in minus 1. Okay, now I have, whenever I find any 9, so I make my index as equal to I. Fine, and I'll say continue. I say continue. Now when this loop breaks, then my I will be at this and my index is storing this value. So now my index is storing last 9, like last 9 here, and the index minus 1 is storing the first number. Index minus 1 is storing the first number which is not equal to 9. Fine, and this is what we have to do. I will decrease this by 1, so decrease by 1 and increase by 1. I hope you guys are getting what I'm actually trying to say. So this is how I'm going to like solve this. So this is for when we have the smallest number and we have to find the second smallest number possible. So I hope you guys are clear with what I'm doing here. Like this is what I'm doing. Okay, fine. Now I'm going to tell you how to find the smallest number possible. Like, okay, one more case I want to discuss here, that if all digits are 9, so in that case my index I will be equal to 0, and index minus 1 will be nothing. Like if I have 9 9 9 9 9, then my index will be storing 0 at last, and index minus 1 is minus 1. So if my index is double equal to 0, then it is not possible, then I have to return minus 1, because in this case it is not possible to find the second smallest number. Fine. Now let me talk about a very important thing. How to find smallest number with same digits. Okay, with d digits and s as sum. Actually, if you search for this problem on Geeks for Geeks, then you will find a different problem. So we have solved one problem, and now we are going to discuss another problem which is a prerequisite for the today's problem. Okay, fine. So let's talk about this problem. This problem says that you have D digits and S as sum. So D as digits and S as sum, and you have to find the smallest possible number which is having D digits and sum as like S. Fine. Let me draw a box, and this box is going to store all the possible digits from like 1 to D. Fine, like 1 digit, second, third, fourth, and up to D. Okay, fine. Now if I have some values like here A, B, C, D, and like let's take any value here, let's say P. Now in this, if I have to make this the smallest number, in order to make it smallest, the approach is going to be increase this value and decrease this value. Like if this value is maximum possible and this value is minimum possible, then I will get the smallest possible number. Okay, so what I will do is, if I have like sum, so I will take the greatest value possible here. So greatest value possible, which is a single digit, is 9. So I will try to write 9999, and if it cannot be 9, so I will write the same number here. Let me give you an example, and after that example you are going to have the clear intuition. I am going to take my example as 26, like sum equals to 26 and D equals to like 3. Okay, it says that you have to find a 3-digit number and you want sum to be 26. Okay, so this 26, you can see that this 26 is greater than 9. So you can write the maximum possible digit here, which is 9. You will write 9 here, and after that you will subtract 9 from this, so it will become like, okay, it will become 17. Fine, now you have 17, and this 17 is again greater than 9. No, there is no doubt. Then you are going to write 17 here. Oh, look, like 9 here. Okay, let me write the code along with this, what I am doing. So I will do something like I am starting from the last index. So 4 int I equals to D minus 1, and I is greater than equal to 0, and I minus minus. I am writing the code along with the explanation. So now if my sum is greater than equal to 9, in that case I am making like answer. So I have an answer array. So I am making answer of I equals to 9, and after that I am decreasing some 9 from this sum. This is what I have done. I have written like now I have written 9 here. Now 17 minus 9 is equal to 8. Fine, so now I have 8 as my sum, and 8 is something which is smaller than 9, so I can't move forward. Instead I will try to write 8 here. So I have written 8 here. So else, like if it is smaller than 9, then I will do two things. First of all, I will write the sum. So answer of I equals to sum, and after that I will break. So this is what I am going to do. But now what you are going to do after this is, you are going to write the same code for the like problem, and now you are going to get an error, and so you will get an error. Let me talk about that error, and this is very important concept. I want you to understand this, and even it is very interesting. I find this problem very interesting based on mathematics. So mathematical problem are something which increase your logical thinking ability. So now let me talk about the case. I have my sum as 18. Fine, I have my number of digits as like 3. Okay, so I want to find a 3-digit number which is having 18 as the sum of digits. Fine, so according to the previous code that I have written, you will do one thing. You will check that, okay, you will draw a box which is having 3 digits. You are currently here, so you will see that, okay, it is greater than 9, sum 18, so I will write 9 here. I will make it 9. Fine, after that you will see that, okay, 9 here, right here 9, make it 0. After you will see that, okay, this is 0, and it will become 0, and this is the answer. But wrong, this answer is something which is wrong. Why this is wrong? Because this is not a perfect 3-digit number, because I want at least 1 at the starting index in order to have the smallest number. Like if I have a number, D-digit number, so there should be at least 1, and this is how a digit start. Like if there is 0, then it will become D minus 1 digit number, so at least 1 should be there. So what I will do is, I will take 1 from S and I will store in my answer, because I want at least 1 in my answer. So what I will say is, hey, if you are 18, then give me 1, because I want at least 1 in my answer as the starting digit. So I'm going to modify it. How I'm going to modify it? Let me do it. I'm going to write like 1 here, and this is a 3-digit number. I will start from here, but I will write 1 here, and now it will become 17. I'm taking 1 from this and I'm writing 1 here because at least 1 should be there. Fine. Now I have 17. 17 is something which is greater than 9, so I'm going to write here 9. After that I have remaining 8 and I will write 8 here. So this way you will get 189 as your answer. So this is the thing that we have to notice, and now I'm going to modify the same thing in my answer. Let me modify it. I have my answer, and then I'm going to make my answer of 0 equals to 1, and after that I will make like sum minus equals to 1, like 1 will be subtracted from this sum. Fine, this is the pre-processing. After that I have this loop. In this loop I am going to do answer of I plus equals to 9, because answer of I like answer is currently having this one value at the starting index, and I want this value to be added. Like if I have 8 at the last, so I just don't want to override this 8. Instead I will make 8 plus 1 as 9. Fine, I hope you guys are getting what I'm actually trying to say here. So now I will make answer of I plus equals to 9, and here as well I will make answer of I plus equals to s. So this is the exact code that you are going to write in order to solve the problem. Okay, fine. Now our main problem was like this one, second smallest number, and I have explained the problem. So now I am going to show you the code. Let me show you the code. Okay, here you can see that I have Java code written here and I have C++ code here. So now this is the part, like this is the part where I am calculating the second smallest number. Okay, so this step I have done below, but you can write this step as here as well, it doesn't matter. But what I want you to notice here is, okay, we have found our like smallest number possible in this. You can even rewrite this code by modifying it. So what I will do is I will do something like I will cut it and I will write my int smallest equal to find smallest, and it is going to have s and t. Fine, so this is how you modularize your code, so it becomes more easy to understand. So I will have a function here which is give me the smallest, so I have int s and int d, and now I will write the same thing here. Okay, so I have function and I'm going to return this smallest. This is how you can do the same thing for the C++ code as well. So first I'm finding the smallest number, and after that I'm doing the same thing that I have told you. Like I'm finding two indexes. Like you can see that if sum is smallest I is not equal to 9, then I will break, else I will store it into like index. Okay, fine. And if my index is equal to 0, again the same condition that I have explained you in the problem, and at this position I am doing like smallest of index minus 1 and smallest of index minus 1 plus 1. Fine. And this code is just for converting this smallest array. Actually the answer is this smallest array, but we have to return a string. So this is what I am doing here. So this is just for like changing or return type. So this is all about this problem. You can even see the C++ code. Fine, now I hope you guys got the clear understanding how we are going to solve this problem, what is the intuition, what is the approach we are going to use. Okay, so this is all about this problem. Thank you.